Hey everyone, welcome back. In this video, we're going to look at an example of a confidence interval for a population proportion. This comes from chapter 18. So this problem says a student organization wants to start a nightclub for students under the age of 21. To assess support, they select a simple random sample, is what SRS stands for. They select a simple random sample of students and ask each respondent if he or she would patronize this type of establishment. In the time available, they were able to obtain 356 responses, of which 70% said yes. Calculate and interpret a 90% confidence interval for this situation. What is the margin of error? So we haven't talked about the margin of error yet. We'll go over that in this example. There's no new calculations or formulas. It's just a piece of the overall confidence interval formula that we've already seen. So you can kind of see as I was reading through this, I was kind of underlining things that stuck out to me. If you want, go ahead and take a minute, pause this video, try to see if you can find everything that we need for our confidence interval formula. You won't be able to find everything straight from the problem, but you should be able to find p hat. You should be able to find our alpha. So p hat, alpha, we'll have to find the z alpha over 2, and then we have to multiply p hat 1 minus p hat over n. And so try to find these three things that we need to solve this problem. If you want to pause this video, go ahead and give it a shot yourself. Also try to think about why this is a proportion problem. So hopefully you've paused it and thought about those things, found p hat, alpha, and n. We'll go over it now together. So in this problem, this student organization wants to start a nightclub, and they ask each respondent if they would patronize or support this type of establishment. So that's a yes or a no. Maybe there's maybe you have a third option of maybe, right? But I think the thought or the intent is that this is a yes or no option, right? So because they want to start that, their p hat, which is x over n, where x is that trait that they're looking for. X is the number of students who, would support, right? The nightclub or whatever. And then you take that number, right? Divide it by your sample size. So again, it's a categorical variable. It's yes, no. So you take the number of yeses, basically, divide it by the total sample that you asked, and that would give you your p hat. We're not told how many specifically said yes, but we are given the p hat directly, the proportion or the percentage that said yes was 70% or 0.70, right? Alpha, we're also not told directly, but we are given that the confidence level is 90%. So if our confidence level equals 100 times 1 oops, minus alpha percent. We know our confidence level is 90%. So if we divide both sides by 100, divide by 100, divide by 100. We're basically just getting rid of this 100 on this side. This goes from a percentage to a decimal. And then we're just left with the 1 minus alpha from the inside. We could add alpha to both sides, right? A little bit of algebra here. So we get 0.9 plus alpha equals 1. And then we subtract the 0.9. Oops. Subtract the 0.9 from both sides. .90, and we get that alpha equals 0.10. This is the, kind of way to mathematically do it. But if you think of the confidence level, the alpha is really just the difference between the confidence level and essentially 1, right? If you just change this to a decimal, subtract 1, that's how you get your alpha. You can do it this way if you want as well. And then our sample size, right? They were able to obtain 356 responses, right? So that is our sample size. It's how many people they asked. All right, so I think the last thing we need to find is our z, say 0.10 divided by 2. So this is z, right, with 0.05 area under the curve to the left. So we can use inverse norm just of 0.05, or if you want, we could use that formula, the confidence level divided by 2 plus 0.5, whichever one you feel more comfortable with. Our confidence level was 0.90, right, for that 90%. You divide that by 2, you get 0.45 plus 0.5, and this is 0.95. So just to kind of illustrate this, right, these two z values that we just found, we found, well, what we will find once we plug these into our inverse norm function is the z values, which are the cutoffs such that 90% of all of our sample proportions, right, are inside this interval. And if there's 90% on the inside, then that means there's 5% below here and 5% above here, right? Because our normal distribution is symmetric. So if you have 90% on the inside, you got 10% left over altogether, hence our alpha. And then we have to divide it by 2, right? Because it's an interval. So we've got 5% below, 5% above, and here's our 90% interval. So this value, if you plug z of 0.05 into your calculator, this is that negative z value you'll get. And then here's the z of 0.95. So 0.05 is pretty straightforward, right? There's 0.05 area under the curve to the left here. And this is 0.95 because from the left of this cutoff, we have 0.90 here from our interval. Then we have to add this 0.05, right? That's also to the left. So either formula, whichever one you're more comfortable with, you can either just divide the alpha by 2 and plug that into the inverse norm, or you can use this formula here to get that upper z level. So this is unfortunately all going to disappear once I plug in, once I switch my screen and share the calculator so that we can get the 0.05. Notice this is a 90% confidence interval, right? So it's going to have a different z cutoff than the 95% example we looked at in the last video. When we had 95% area under the curve, in between our interval, we were left with only 0.025 area under the curve to the left, right? So that line would have been pushed out a little farther to the left, with half of the area only 0.025 under the curve instead of 0.05. Same thing over here. So write down what you need to, pause the video, and then I will find our z of alpha divided by 2, and then all we have to do is plug in everything else that we know and do some arithmetic. Okay. So let me pull up my calculator here. Give me just a minute. And I will share my screen. Okay. Here we go. All right, so to find the z-value cutoffs we're looking for, when we know the area under the curve, we use our inverse norm function, right? Option 3. I'm going to plug in that 0.05, which was the lower z-value. The upper will be the same value. It'll just be the positive value. So we plug in 0.05, that's the area to the left. Remember, ignore this. Your calculator may not have this option. We always just want to put the area to the left on our inverse norm. We're talking about z values, right? So we're talking about a standard normal curve with a mean of 0 and a standard deviation of 1. So we just hit enter, enter again. So our z value for a 90% confidence interval is going to be plus or minus 1.6448. So we can round that up to 1.645. So we'll go back to the example. And now we can just plug everything into our formula, right? Which was, whoops. P hat plus or minus RZ alpha over 2. P hat 1 minus P hat divided by N. Okay, so we know our P hat is 0.70. We need to add and subtract that from the 1.6. 45, I believe, was the z value we found. And then we have to multiply 1.645 by 0.70, 1 minus 0.70 divided by 365, right, the square root. And then everything, not including the plus and minus, but everything to the right of the plus and minus, this whole thing is going to be our margin of error. I'm going to abbreviate it as MOE, right? So it asks us to find that margin of error. So no extra work really or anything. The plus and minus, right? is just called the margin of error. So I'm going to start on the inside of our square root, 1.645 times the square root, 0.7. 1 minus 0.7 is 0.3. It's a closed parentheses, 365. So 0.7 times 0.3 0.7 times 0.3 is 0.21. Keep losing my mouse. So that's 0.21 in the numerator. I'm just going to write that 2.1 divide by 365. 0.21 divided by 365 is equal to a small number, 0.000575. But we take the square root of that, and that becomes 0.02398. So just looking at this piece first, right? Kind of just doing that step by step. So now what do we have? We have 0.7 plus or minus 1.645 times this 0.02398. You multiply that by 1.645, I get 0.039. We round up. So this right here, this 0.0395 is our margin of error. And then if I do 0.7 plus this and 0.7 minus this, let's do the addition first, right? That'll be our bigger number on the right of our interval. And then if you do 0.7 minus 0.0395, you get 0.6605. So we're 90% confident that the true proportion of students, at the school who support this nightclub is between 0.6605 and 0.7395, right? And so we could write this as percentages if we wanted to, but that would be our final answer. All right, see you next time.